Hello, everyone. Thanks for joining us today here at the webinar on building and scaling RAG applications. We are going to get started now. So over the next few minutes, what we are going to do is we are going to talk about building applications and scaling those pipelines with retrieval augmentation generation, right? RAG has been kind of a thing lately when it comes to building applications leveraging LLMs. We all know LLMs are very good at kind of understanding the context and the documents, but when it comes to the recency and tuning and using it with the data that is very proprietary to your businesses, there have emerged various techniques and architecture patterns which allows LLMs to be used along with your applications. And one of them is RAG. And in this kind of session, we are going to kind of dive deeper into the architecture of RAG-based applications. More importantly, how do you kind of go about productionizing those applications? Some of the challenges that we have seen while running them in production, and eventually, how do you scale that to kind of handle, multiple workloads, business complexity, and all of those things. So, just as a primer, and some of you might already know about this, but what is retrieval augmented generation? So this is essentially an AI framework that allows you to kind of retrieving fact from an external knowledge base and to ground the LLMs on the most accurate and up-to-date information. Typically, LLMs are pre-trained on a set of data which is a lot more general purpose, right? When you think about GPT from OpenAI or Llama 4EB and so forth, they are trained on the information that is not available to them, based from your company. So, like for example, if you are in a specific domain and you have your own proprietary data, these models are not going to be trained on that. So, how do we leverage the LLMs to be able to use the proprietary data that belongs to the company in a safe and compliant manner? This is where RAG comes into picture, right? So it works with your data. It also helps reducing AI hallucination because, instead of just asking a very open-ended question, you are also giving an LLM a context, right? Which is very much specific to the problem at hand with the data that you have. And this allows kind of them to be a lot more accurate, and you can also fine-tune the prompts to, just not give an answer if they don't have enough context there. And eventually it leads to, being able to make a lot more data-driven decisions as opposed to kind of, just trying to parse the output from an LLM and try to make sense out of it. So let's take a look at it, right? How does a typical RAG-based application work? So you have a user query. Take, for example, let's say you are building a knowledge-based system that allows me to query. We all drive cars, right? So let's talk about that, right? Let's say I have a problem with my car's engine and I want to find out what's going on there. So that's my query, right? It ends up with an orchestrator that does a couple of things, right? One is it takes the user text as an input, generates the embeddings, which is then used against a vector store to search the relevant documents that matches, and that essentially serves as a context that this is the context in which the question is asked. And this becomes a lot more semantic search as opposed to just like a free text search or more the query based on database parameters and things like that. Now combine that context with the prompt and you send it to the language model that essentially generates the output that is then served back to the user. So that's how you essentially use it at the runtime. But what about how do you actually hydrate that vector store to begin with, right? And this is where the data pipeline comes into picture. You have a set of documents and they go through essentially an ETL pipeline. You are kind of reading this document. So, these are PDF files, you are ingesting PDF files, getting the text out of it. If these are images, maybe generating the text out of images if these are scanned documents. And then comes the transformation. And this is a critical piece, which is very contextual when it comes to the type of documents that you have, right? And there are two ways to kind of think about it. One is you can just split the documents randomly at, let's say, every 10 kilobytes. Or it can be a lot more kind of semantically aware when you know the structure of a document. Let's say if you think about indexing a text written document, we know that there are specific sections to the text written filing, and it can be split according to that. That makes it a little bit more and actually a lot more semantically aware in terms of what this text contains. Right? Sometimes you also want to enrich that data with a lot more information. A lot of times, you're enriching that with reference data or doing some sort of cleanup to remove the noise, unwanted information, and so forth. And eventually, those chunks they are fed into an embedding model that generates the embeddings. These embeddings are then ends up in a vector store, and that's essentially kind of starts building your knowledge base. This pipeline runs probably multiple times during a day, multiple times, or maybe every day, depending upon how recent the data you want it to be and the nature of the data. And this can run at scale. You could be indexing and ingesting, let's say, 10 documents or 10 million documents or 10 billion documents, right? Depending upon your use case and what is it that you are trying to do with it. So we talked about how a RAG-based application runs in a production environment, what goes into at a high level, indexing data into the production environment. Let's talk about how do we make them production ready. Like when it comes to, so you have your POC, you have a kind of proof of concept ready, and it seems it's working. So what's next? What comes next here, right? So the first and foremost thing, and we all know probably about this a little bit here and there, is about managing prompts. You do not want the prompts to be open-ended. There have been kind of various studies, papers published, and a lot of research done around like prompt injection, keeping safety around the prompts. The second part is securing access. Take, for example, you are training your models and indexing data on your company's financial data. Do you want this to be accessed by everybody? Probably not, right? What if you have fine-tuned a model using this data, and you do not want everyone to go start querying about last quarterly misses or current revenue and things like that. So that's the other piece that you need to think about, is how am I going to secure the access to this information, just like you would do with a typical database. The third piece is like, how do I actually manage the ingestion pipeline? There's one time when you think about ingesting data, you are ingesting either, as I mentioned, right? Like maybe you are probably indexing 10 documents or 10 billion documents. And this starts to become a lot more challenging if you were to do this at a high scale, right? Maybe multi-gigabytes, terabytes of data that you are ingesting. You have to now have the pipeline, and larger the data set, chances that something is going to fail in between becomes higher and higher. And that probability, as it increases, you also have to start thinking about how do I kind of handle those failures that are very transient in nature, be able to kind of rerun it at a point in time, if required, rerun a specific part of it if the data changes, and so forth. And at the same time, when we think about ingesting data into vector database, we are also spreading the documents that kind of in some ways matches the context length or the window of your runtime model. Early days, this window used to be very small. As the models are improving and enhancing, this context window also is increasing. But it has a direct correlation with the cost as well, right? Like as you increase the amount of context, it not only increases the number of tokens used, that has a direct kind of relationship in terms of the underlying infrastructure cost, or if you are using it as an API, the API cost as well, and overall latency, right? So you have to also kind of experiment with those parameters to see what makes the most sense and what gives you the right answer for most part. So that's another piece which you need to kind of experiment before it is kind of finalized. And in the end, if you think about it, right, you are orchestrating across multiple systems here now. You are working with your data, which is probably stored in various document store. You are working with your regular relational databases, which is where you are probably getting data to enhance your kind of input to the vector database. You are also adding data to vector store. You are leveraging the embedding models like FICE from Facebook or OpenAI embedding and things like that. You have your own fine-tuned models that you might be using, or using an open source model or a hosted model. You are working with them. All of them have their own kind of quirks and availability guarantees in terms of how efficient they are, how long does it take for them to give an answer. And if you change from one model to another model, sometimes the semantics changes, like you have to think about how am I going to test them out in terms of the efficacy and the correctness of the answers. Now, in the earlier example that I showed here, and let's just back up a little bit, right? This is a very simple example of an RAG-based application, right? Where you have a question, it goes through the retrieval and generation process, and you give that the answer. But oftentimes, it is not as simple as that. If you think about, let's say, a very long-running chat example where you don't want to cold start a chat with a user. You probably want to also retrieve the previous history of what has happened. So now comes the question of how am I going to build queries which are a lot more stateful, which understands what was my previous context. And what if my current conversation starts to become longer and longer? Then there are techniques where you can also leverage RAG to kind of make your chat also a lot more like longer in terms of the length by indexing data into VectorDB and retrieving the relevant information to continue the conversation. And last but not least, when you think about a lot of new frameworks that you see today, right, they mostly focus on Python, given the roots of this is in the data science. However, when you think about building production applications, oftentimes, the production apps tend to be written in much different set of languages, right? We are talking about Java, C#, Golang. How do you kind of take the same approach and make sure that they work across the board? And you essentially end up with two different kind of personas here, right? You have the data pipeline, which is typically written in Python, the huge amount of tool set there. If I want to read a PDF file, probably 5 lines of Python code that can get my job done. But then I want to build a UI application. I probably don't want to write it in Python. I want to use TypeScript. So, how do they kind of interop with each other? That's another thing that you got to think about before, you start building this out into production environment. And then we are talking about scale here, right? And scale is not a single dimensional thing where you say that scale is about handling QPS. Scale goes beyond that, right? It's essentially going from 0 to 1 can be very quick, but going from 1 to n and putting this into production ends up becoming a multi-dimensional problem. You have to have prompt management aspect of it, somebody looking at the prompts, making sure that if there are problems with the prompt in terms of the security compliance, then you are able to change, and once you change it, it applies to everywhere. So some way of managing and templatizing prompts. You have to manage your ingest pipelines. All of these things are very long-running asynchronous processes. So you have to start thinking about building applications which are very much asynchronous in nature, and you are able to kind of retrieve the state, continue from where it left off, handle failures and so forth, right? And you also have, as we talked about earlier, right, you potentially also have stateful interactions where you have to be able to sometimes retrieve what had happened, in my prior conversation, and that conversation could have happened 2 days, 3 days ago, or even longer than that. Retrieve it, make it part of the current conversations, and then continue forward. So all of these things starts to make it a lot more complex than it seems when you start thinking about building this kind of applications. So we talked about, at a high level, architecture of a RAG-based application split into two things, right? Like how do you ingest data? How do you run the application at runtime? And some of the problems and some of the challenges that come with building this kind of applications. So how do you kind of solve for it, right? And where we built the Conductor and Orkes Conductor specifically, right, was to solve some of these problems. And some of these problems are not very specific to RAG applications alone, right? Things like, for example, access control, statefulness, long-running asynchronous processes, handling failures and all. These are the common concerns that typically applies to any and all applications that you are building or could be building. And this is where we had built Conductor, which is an open source project. So feel free to check it out. But Conductor is designed for that, right? It is designed for building and managing large-scale data ingestion pipeline. It's very much polyglot. So it goes beyond just Python to be able to do write a single application with multiple languages, right? The paradigm there is you don't have to write an application in one language. You can write one application in multiple languages, And parts of the applications can be written in a language that makes the most sense for it to be written in. And of course, it integrates with popular models. So it integrates very nicely with OpenAI, Google's Vertex, and so forth, and including open source models hosted on Hugging Face or as AWS Bedrock. That allows you to kind of work with very different set of models, build your applications. And more importantly, security and access control is a very first-class primitive. When it comes to productionizing and running this in enterprise, this is essentially kind of a table stakes, right? You need to have security and access control as part of it. And the same goes with prompt templating. Prompt management is something that is part and parcel of building any AI-based application. And Orkes lets you do that very seamlessly. And finally, why this was built, right? To be able to handle failures, retries, rate limits. Like we often see this with the models where if you are running a model through an API endpoint, you end up getting a rate limit. How do you handle the rate limits? With Conductor, you don't have to even think about it. You'll just automatically retry, take care of rate limits and all of those things. In the end, what happens is, when you are trying to build applications, you don't have to think about all of these aspects of and the complexities around building a RAG-based application, and you can focus on starting to build and drive the business value. So what I'm going to do is, I'm going to spend a few minutes just talking about a real world use case, right? We talked about some of the aspects of Orkes and how it works. The best way to kind of demonstrate is probably going to be, let's just see this, how it runs in a real world environment, right? So what we did was, we essentially kind of built a simple a search engine that works on Orkes' own documentation, right? So oftentimes what happens is, you are using Conductor, you have a question about an API endpoint or a feature. And typical way is, you look at the documentation, find out the relevant documents and look at it and find out, right? With AI, the whole thing can be a lot more shortcut. You can actually, ask a question and, get an answer. So, a very simple and the most powerful use case when it comes to RAG-based application. So how does it work, right? So again, two parts, right? One is how do you index and how do you query? Indexing is essentially two parts here, right? You get the URL for the site by parsing the sitemap that is typically available for all the sites. And then for every document that you have, every page that you have, you essentially index the document into a vector store. And that's pretty much it. So it looks pretty simple, but let's dive a little bit deeper into it. So I'm going to show you the workflow that does this. And this is the real workflow in action. If you think about it, it takes the sitemap URL. So, if I dive deeper into this, it's a very simple workflow that takes input as my sitemap URL and produces pretty much every page that we have. So, close to 190 different pages. So my job is I need to index all of these things. This can get complex, but it's simple enough with Conductor. And what we are doing is, these are all different pages. There is no kind of serial execution needed, right? So I can run them all in parallel. And it is as simple as, putting them into parallel fork. So, let's see if I can show this in the UI in my browser. Probably not. It's a really big one. But I can run all of this thing in parallel, which means, I can save time. In this case, these are relatively small documents, but this can go really large. And if they become really large, the parallelization helps kind of reducing the time it takes to index the documents. And depending upon the workload, some of the things can run in parallel, some of the things can kind of wait and so forth. But indexing essentially is what? When you think about indexing is you take the document, you specify which database you want to put it into, your index, which is the embedding model provider that you're going to use, and the document that you want to index. That is pretty much all you have to specify. And it goes around and indexes. As you can see, right, like I'm writing very minimal set of code here. It is doing most of the heavy lifting for me in terms of, parallelizing the work, making sure all the dependencies are met. If any point in time here, if the things fail, it is going to kind of retry automatically if there are rate limits enforced by, let's say, OpenAI, and in this case, I'm using Azure OpenAI, it is going to wait until they get a free slot and continue forward. But that makes it as simple as creating a simple workflow with something like this. And I can analyze this, right, in terms of what's my performance is. Like I know, for example, here, every page takes about 5 to 6 seconds to index. And I'm parallelizing it. So, if I look at the overall time, is only 1 minute, less than 2 minutes to index about 200 pages, 5 seconds each. But, I have the advantage of running this in a parallel environment. So that's the first part. Now let's talk about the second piece, which is essentially, how do I query at runtime? So let's say now when a question comes, the question could be, as a user, I want to terminate a workflow and I want to find out the API to terminate the workflow. What do I do? So typical approach is going to be, to figure out all these things manually. But with a RAG-based application, this can be really simplified. So first part here is that I have my question, I generate my embeddings for the query. So, the text gets converted into embeddings. Then we are searching the vector DB for the documents, ranking them in the most relevant one, and we pick the most relevant one. That becomes the context. This context goes to the LLM, and we use the OpenAI's text complete model here to specify, two things, right? The context and the name of the prompt template, the template that is going to be used to generate the answer. And it gets the answer. Now, the template is configured in such a way so that if the context does not have enough information. So let's say if I ask a question, how do I drive a car using Conductor? Of course, Conductor is not a self-driving system. So instead of giving me an answer which is completely randomized and hallucinating, it's going to give me an answer saying, I do not know. And that's how the prompt is created. And then we are looking at the prompt to see if it is giving me an answer saying, I don't know. If it is no, then I'm going to route this to a human task. And this essentially is a very powerful feature when you think about RAG-based applications, is that, in the current situation, the way you want probably to use it is, when you are putting this in a production environment, you want to probably rank the output of the LLM with some level of confidence. If you are confident enough that the answer is accurate, then yes, you can proceed further. But in case of ambiguity, in case of LLM not being able to give the answer because you did not have enough context, or the answer seems not confident enough, you probably want to route this to a human. And this is where the human in the loop kind of works at play, right? So Conductor allows you to essentially put humans in the loop. So in our case, essentially it gets routed to a human to look at the answer and say, hey, this was the question, I don't see the answer, can you answer? And then somebody can type in the answer or correct the answer, and it continues and essentially goes forward, right? Our typical integration here is with Slack. So whoever asked the question on Slack gets responded back, but in this case, the response might come from a human as well if required. So let's take a look at it in action, right? And I'll show you a very simplified version of this. But here's a very simple document search question, right? How do I restart a workflow using Java? Maybe I'm a Java developer and I want to kind of run this in Java. And there are two things happening here, right? Like one is, it is searching the input text into a vector DB and try to find out the matching documents. And if you notice here, right, like some of the parameters that I'm controlling here are things like temperature, right? We do not want this to hallucinate. So, temperature is set to 0, only give the answer within the context, and it has to be repeatable answer. So if I run this workflow 100 times, it's going to be very consistent. This also gives me kind of advantage of being predictable in terms of, what my output is going to be. So, here is my output, right? Like this is the context that I got, is the text. And as you can see, right, this text is not something that I can really send it back to the user. It's a fragment of the text that was indexed. This goes into the LLM as a context, and here is the prompt, right? Answer the question based on the context provided, and here comes the answer. And it actually finds the exact API endpoint that I can use it to achieve my goal. So it's as simple as that. Now I can run this in a production environment at scale. I can look at the output of the thing, make it more complex in terms of being able to look at a decision tree maybe even look up a database. So, when you think about multi-agent workflows, it starts to become a lot more complex, right? You are not only just using RAG to do this, but you are also kind of using it to build a lot more stateful interactions across multiple systems. So how did I do all of these things, right? Of course, Conductor is not a low-code system. It lets you write less amount of code because you don't have to worry about things like how do I handle retries and failures and all of those things. But in the end, here is a very simple kind of fragment of code that is written in Python, but you have various tasks available that you can put it together. And if you are familiar with many of the frameworks that are out there for working with AI, this will seem very familiar, where you have various tasks that you are chaining together. The advantage with Conductor is that everything runs in a distributed environment. So, whether you are running a single instance or one instance or one query per second or a million queries per second, you don't really have to go and change your code or make any changes to your code, right? It will scale from one request to 100,000 requests as long as you are working on an infrastructure that supports that. And it takes care of things like handling retries and failures and all of those things. The other piece, when it comes to things like data pipelines and even queries, is it guarantees execution, right? Conductor essentially is a framework for writing very durable applications. So the moment you start your pipeline, it guarantees that it will complete either in a terminal state with a failure. If there is a problem, like for example, you have missing files and you don't want to proceed without those to be available, or in completion stage successfully. But either way, it will complete. It will not be left hanging. And the way it works essentially is that Conductor acts as an orchestrator. It's an orchestrator that lets you build very powerful stateful applications using a combination of AI models, humans, serverless, microservices, monoliths, and everything together. So as we come towards the end of it, right, like the question then comes is, how do I get started? So the best way to get started is sign up for Orkes. It's a very powerful, it takes few minutes to get started, and you can try out all the examples that I've shown here on the GitHub repository that is kind of listed below. And again, Conductor is based on open source, so feel free to give it a try on conductoross.org, and if you like it, definitely give us a star. With that, we'll open up for Q&A.
Awesome, fantastic. Thank you for that session, Viren. Really super interesting stuff. We have quite a few questions in the chat. I do just want to let everybody know that we did record today's session. We will be sending out some follow-up emails with the recording and a couple of additional offers. But I want to go ahead and just open up for some of the questions that we have. So please use the chat or the Q&A function in Zoom to add any questions that you'd like. We'll answer as many as we can. The first question is, how is this different from LangChain?
Right. So so let's start with similarity first, right? So how is it, what's kind of, what is Conductor and what is LangChain, right? So LangChain is a very powerful framework and a set of libraries that allows you to work with data as well as language models to create the application code. And it's a very good one at that. What Conductor does is that that code that you've written using LangChain libraries or your own custom libraries, it allows you to kind of run them on the server side and productionize them, right? So think about it as like, you have a main method that you've written bunch of code that allows you to run on your laptop. That's LangChain. And then when you want to run it in production, you have to package it and run it as a server-side component. This is where Conductor comes into picture. So that's the primary difference. Conductor is a runtime, it's very language and framework agnostic. So you could be writing your code leveraging LangChain libraries to kind of parse documents, for example, or other open source libraries to parse documents and so forth. And Conductor lets you run them at scale.
Awesome. We're going to keep powering through some of these questions. The next one is, why would I need a platform to handle this?
That's a great question. When you think about applications of this nature, right, there are certain characteristics to it, right? So let's kind of quickly jump back into one of the earlier slides. So one is, imagine a scenario where you have hundreds of applications leveraging LLMs, and every application has kind of the prompt that is hard-coded or even configured inside application deployment. And a security researcher or somebody from your company or outside or your team, right, finds there are problems with the prompt because they are susceptible to prompt injection and something. How do you go around changing hundreds of applications and deploy them to production? This is one thought, right? Second is you could be using a completely open source model, or you could also be fine-tuning the model with your own company data or the proprietary data. Imagine I am fine-tuning a data with my let's say HR data, right? So that I can build very powerful HR co-pilots that allows my team of HR to work with their day-to-day operations. What if an employee gets access to this model and starts asking questions about, hey, what's the salary for my boss or my colleague, or why didn't we get the bonus this year, and things like that, right? Similar things, you want to make sure that it is only available to everyone, not everyone, but rather only people with authorized access, right? It can have regulatory and compliance issues as well. Third piece is that, like, oftentimes when you are dealing with data, we are talking about large amount of data, right? Multi-gigabytes, terabytes, and depending upon the nature of the data, if you are not able to handle the failures in time, detect them, fix them, it could mean loss of time, and oftentimes, especially let's say if you are working in a financial services industry, the time directly equates to the money and the financial impact, right? So how do you kind of do this at scale, at the same time keep it simple enough so that you can do this fast? The other piece is inherently everything when it comes to LLM is asynchronous. Oftentimes, the responses take a few seconds to come. Sometimes they fail. You have to have kind of multiple kind of checkpoints in between humans. All of these things requires a platform to run. If you, and of course you can build the platform by yourself, but the question that you want to ask is that what your kind of primary goal is, right? If I'm a company that is focusing on e-commerce, my job probably is to make sure that our e-commerce process is as seamless and as efficient as possible, rather than trying to build a platform to run language models based application.
All right, great. It looks like we've got about 3 more questions we'll try to get to. This one looks like it's a bit detailed, but I think it's a good question. Could someone using a mixture of models route requests to multiple LLMs? Can the compute for running on a fine-tuned version of each of the LLM use Conductor? I have a few pipelines and workflows that I run as part of my RAG workflow. Can I use Conductor for orchestration?
Yeah, absolutely. And I think this is one of the reasons why Conductor excels, right? Like today, for example, let's just quickly go back to this thing right here. So this is the workflow that take, for example, sends the request to in this case sends the request to OpenAI. But I could very easily modify this to run in parallel and send a request to OpenAI as well as Mystrial 7B, for example, in parallel, rank the results, and then pick the one that is the best. This is when basically you want to kind of pit multiple models against each other and get the best one out of it, right? Or the fastest one. So you could do one of those things. Second thing oftentimes is, and then we have seen this also, is that you kind of pair another model together as a observer, and it is kind of like looking at the output, also kind of evaluating the output of another model, and kind of making some sort of critical assessment on it before, so in some ways, you are kind of assessing the output of a model in terms of assessment of how accurate the information is, or if you can find something there, because these are all kind of 2 different models. The hope there is this can give you a better accuracy in terms of identifying if the result is good enough or not. And also you can potentially also leverage it to test a new model that you are trying out to see how it fares and compares. And once you have enough confidence, you can kind of get rid of the current model and swap it out with a new model. So yes, absolutely. I think these are some of the very kind of powerful use cases that we have seen and being employed, and they keep evolving, right, as things are kind of progressing in this area.
It's a great answer. Awesome. Let's answer one more. So among the community, do you see any use cases that makes things inherently easier from the things that you've shown today? So it sounds like they're looking to see of our community, what kind of things that you've shown today are people doing, and are there common use cases?
Yeah. I think the most common use case that we have seen so far is around document intelligence, right? Oftentimes, what happens is that you have a treasure trove, right, of documents sitting inside the organization. Like, this could be the user forms, this could be internal documents, and a whole bunch of things. Now, if you want to get intelligence out of this, it would require a massive amount of effort if you were to employ humans. And even with even if you want to build custom AI models to kind of do this, that becomes a lot more challenging task. So this is one of the use cases that we have seen, is that, hey, I have a whole bunch of documents that were submitted over the last 50 years. Can we get some intelligence out of it? Like, let's say I'm an insurance company and I'm looking at all the insurance claims. What are the common patterns that are emerging? Which ones have missing information that we had to go back and forth? A lot of intelligence that are coming out of it. So this is one of the most common use case that we have seen is around document intelligence.
That's great. Thank you for that. It looks like that's all of our questions. Viren, thank you for the presentation today. Thank you everyone who attended and did ask us questions. If you'll look in the chat before you exit, there is a clear link there to get started. We would love to be here to answer any questions for you, help you along in your journey. We will be sending the recording out later today, so be on the lookout for that and additional resources to come. Thanks again for everyone to join.